Okay, so this next lesson is on the atom. So we learned when we did the matter lesson that all matter is made up of particles, and that the atom is the most basic unit of matter. So we're going to talk a little bit about the structure of the atom. Okay, so the atom. The atom is the smallest part of an element that has all the properties of this element. So if you're talking carbon, then carbon is going to be made up of carbon atoms, and all of those atoms are going to have the same properties of carbon. The atom consists of two main parts. Number one is the nucleus, okay? And the nucleus is in the center of the atom, okay? And the nucleus contains protons, and we're going to go into this in more detail, and neutrons. An atom also consists of orbits, and these are shells that surround the nucleus. So this here is an orbit, this here is an orbit that surrounds the nucleus, and they contain electrons. Okay, so these green dots are the electrons. So let's specifically look at the nucleus. Okay, we're going to go into more detail about what a proton, neutron, and electron actually means. So within the nucleus, there are two types of subatomic particles. We have the protons and the neutrons. Protons are positively charged, okay? So protons have a positive charge, okay? Neutrons are neutral. They have, you can think of it as no charge, okay? So we put like that little 0 up top to indicate no charge. So the nucleus specifically contains just the protons and neutrons. Protons are positively charged, neutrons have no charge. So again, this right here, C represents the nucleus. The orbits contain only electrons, okay? Electrons, guys, are negatively charged, okay? So electrons have a negative charge. Number of orbits depends on number of electrons. Okay, so you'll see over in the diagram here, these are the orbits. These red circles or red dots are indicating the electrons. You'll notice that inside the nucleus, you see there we have the protons and the neutrons. So we learned on the last slide, the nucleus contains protons and neutrons, and the electrons, the negatively charged subatomic particles, go in the orbits. Okay? Atoms are neutral, they do not have a charge. So we're going to learn that atoms have the same number of positives as they do negatives. So if you were to have, just for example, if you were to have 2 positives and 2 negatives, well, they're going to cancel each other out. Okay, so if you have the same number of positives as you do negatives, well, if you have the same number of positives as you do negatives, they're going to cancel each other out. So atoms are neutral because they have the same number of protons as they do electrons. Okay, so keeping in mind, protons have the, sorry guys, second. Protons have a positive charge, electrons have a negative charge. So atoms are neutral, they have no charge because they have the same number of protons, which has positive charges, and the same number of electrons, which have negative charges. Okay, so they balance out, they equal out, they cancel each other out for an overall neutral charge. Okay, so just to recap, we've learned that in an atom there is a nucleus. The nucleus contains the protons, the positive charges, and the neutrons, and the orbits contain the electrons that are negatively charged. Okay, so now we will look at the three subatomic particles in detail. So we have protons, neutrons, and electrons. We're going to look at the mass, charge, location, and symbol. So protons have a mass of 1 AMU. So if you look down here, it says AMU equals 1 atomic mass unit. So keep in mind the protons are in the nucleus, and each proton has a mass of 1 AMU. So if you have 1 proton, that's 1 AMU. If you have 10 protons, it's 10 AMUs. Protons have a positive charge. Okay. They are located in the nucleus, and we represent protons with a P, and then we put a little positive up above. So a little P with a positive to indicate it is positively charged. Neutrons also have a mass of 1 AMU. So again, if you have 6 neutrons, that's 6 AMUs. Neutrons have a neutral charge, no charge. They are also located in the nucleus, and we represent them with that little circle or 0 up above. So you can have lowercase as well. Okay, so it can be a little n with a 0 to represent neutrons. Electrons have 0 AMUs for mass. So electrons contribute to very little weight or mass of an atom, So protons and neutrons inside the nucleus is going to make up the mass of an element. So electrons, the mass is 0 AMU. They're not contributing to mass. Just the protons and the neutrons in the nucleus are. Electrons are negatively charged. Okay, they are located only in the orbits, not in the nucleus, the orbits that surround the nucleus, and we represent that with a little e and then a little negative sign up above. Okay, now we're going to talk about atomic number and atomic mass. So we're going to be using the periodic table a little bit more here, and we're going to be able to, pick out specific information in regards to number of protons, electrons, neutrons, the atomic number, the atomic mass of specific elements. So the atomic number is unique for each element. It is the number of protons and the number of electrons the atom has. So on the periodic table, this number here, this 29 for copper in this example, that top number, it's either on a periodic table directly above the symbol. Okay, so Cu is the symbol name for copper. That number is either directly above or just slightly to the left, in the left-hand corner of the box. That is the atomic number, and the atomic number is equal to the number of protons and electrons. So that number tells you 3 pieces of information. It's the same for all 3. The atomic number, the number of protons, and the number of electrons. So keep in mind, if copper has 29 protons, that's 29 positives, 29 electrons is 29 negatives, so that's why they cancel each other out, and the copper atom is neutral. So it says here copper has an atomic number of 29, meaning a neutral copper atom contains 29 protons and 29 electrons. So we have 29 of both the positives and the negatives, which makes it neutral. Okay, so the periodic table tells you different information. This top number above the symbol or to the top left of the symbol represents the atomic number, the number of electrons, and the number of protons. Atomic mass. Electrons have a mass of 0, so we saw that in our table. Electrons are 0 AMUs. They're not making up the mass of the atom. So the nucleus makes up the mass of an atom. So the sum of the protons and neutrons in an atom's nucleus is the mass. So if you're asked to determine what is the atomic mass of an element, well, the mass is made up by the protons and neutrons in the nucleus. So if you have 10 protons, that's 10 AMUs, and if you have 11 neutrons, that's 11 AMUs. So you would add those two together, 10 plus 11, and you would say that it has a mass of 21. Okay? It's measured in AMU. It's measured AMUs. So we have an example here. We have copper again. So top left is the atomic number. So this here is going to represent the atomic number. I'm just going to put here, oops, I'm going to use a different color. Can't see that very well. So atomic number, also number of protons, and also number of electrons. So copper has 29 protons, 29 electrons, and it's this number down here that represents the mass. Okay, so that is the mass of copper. So when we see decimals, we always round so that to a whole number. So we don't want to have any decimals in our mass. So you would look at this 5 here. Okay, 63.546. The 5 is going to round the 3. So let's see here. This 5 is going to round the 3 up to a 4. Okay, so 63.5 is really a mass of 64. Okay, so that bottom number represents the mass. Okay, and that mass, remember, is really the number of protons plus the number of neutrons. How do we determine the number of neutrons? So since the mass of the atom is made up of the neutrons and the protons, whatever mass is not due to the protons must be due to the neutrons. So this is saying, guys, the nucleus makes up the mass, and the nucleus contains protons and neutrons. So if you know the mass and you know the protons, you can calculate the neutrons because the neutrons is whatever is left over. So in order to figure out the number of neutrons, you use this formula here. So number of neutrons is equal to the atomic mass subtract the atomic number. Okay, and remember, the atomic number is really also the number of protons. Okay, that's the same. 29 is the atomic number and the number of protons. So to get the number of neutrons, you're going to take the mass, which in this case is 64, and you're going to subtract the atomic number or the number of protons to get what's left over, which represents the number of neutrons. So in this case, I've shown it here, but number of neutrons is going to be the atomic mass, which is 64, subtract the atomic number or the number of protons, and we get that copper has 35 neutrons. Okay, so here are formulas to keep in mind. So the number of protons is equal to the atomic number and is equal to the number of electrons. So guys, you just have to remember that for atoms, all three of those numbers are the same. That top left-hand corner number on the periodic table for each element represents all three of those values. Mass number is equal to the number of neutrons plus the number of protons, okay? And this makes sense because remember, the mass of an atom is made up by the neutrons and the protons in the nucleus. Okay, so if you have the number of protons and the number of neutrons, that will give you the atomic mass. Okay, and then the number of neutrons is equal to the mass number, or that also means atomic mass. Same thing, guys. Subtract the atomic number. Always bigger, subtract the smaller number. Okay, so to get the number of neutrons, you're going to take the mass and you're going to subtract the atomic number from that, and that is always going to give you the number of neutrons. Okay, which we did in the last slide together. Okay, so we're going to do a couple examples together here. So it's already been written out here, but we'll go step by step. So let's try sodium and argon. So you would look at your periodic table, and you'll all have one as a reference sheet. And you will find sodium on the periodic table. Sodium's symbol is Na. Okay, so you guys look over here. We're going to use this guy to help us. So Na, the atomic number is that top number. So you need to remember that the atomic number is also equal to the number of protons and the number of electrons. So the atomic number for sodium is 11, so the number of protons is also 11. Okay, and the number of, so positive charges is protons, and the number of electrons is also 11. So this should say 11. There's a mistake. I'm actually going to use black. Okay, so sodium has an atomic number of 11, number of protons is 11, number of electrons is 11. Number of neutrons, well, remember, in order to get number of neutrons, you have to do the atomic mass, oopsies, why am I writing? Subtract the atomic number. So the mass is this value right here, guys. So remember that bottom number, 22.99 rounds to 23. So it's going to be 23 as the atomic mass, subtract 11, which is the atomic number, and that is going to give 12 neutrons. Okay? Argon, I don't have the diagram here, but again, guys, you would go to the periodic table and you would use this exact same formatting, okay, and you would pick out the pieces of information for argon. So the top left-hand corner for argon is going to have an atomic number of 18. So that means that the number of protons and the number of electrons are also 18, okay, because all three of those numbers are the same number of positives as negatives, which makes it neutral. And in order to get the number of neutrons, you take the atomic mass, subtract the atomic number. So on the periodic table, you'd see that the atomic mass of argon is 40. You subtract the atomic number, which is 18, to get a total number of neutrons of 22. Okay, that's the atom, and using the periodic table to pick out different information about protons, neutrons, electrons, atomic number, atomic mass of elements. So you got a little bit of practice on page 20 to 21 in your booklet. Thanks, guys.